Welcome to the Week 1 recitation for SciMath. My name is Connor Mikowski, and today I'm going to be teaching you how to use SciMath. Using SciMath is quite easy. SciMath is a great software that can help you with algebra and calculus. It provides helpful step-by-step walkthroughs for each problem, and it accepts a wide variety of inputs. For example, x squared plus 2x minus 1 is the same as x squared plus 2 times x minus 1. It's important to note that this is the only form that edX will accept in its formula-based equations. That's because edX always needs multiplication signs between variables and between constants. Graphing in edX is quite easy. The syntax is simply graph. For example, you can type graph for x minus 3, or as another option, graph y equals 4x minus 3. You can also type graph x squared plus 2x minus 3 as a more complicated example. For now, we're just going to stick to 4x minus 3. We're going to go over to SciMath and we're going to try that now. Once we get in SciMath, we're simply going to type graph for x minus 3. Now, up above, up here, you can see that SciMath automatically lets you know how it's interpreting in that. In essence, we are interpreting that correctly right now. So we're going to hit solve, and we'll see what happens. Now, once it's solved, we're going to look at the graph itself, and we can see that this is the graph of 4x minus 3. Similarly, we can look at the intercepts, asymptotes, domain, and range of this equation. Moving on, we're going to talk about determining roots and intercepts in SciMath. The syntax is simply intercepts and then you state your equation. Or you can type 0 equals and then state your equation. For example, we can type intercepts y equals x squared plus 2x minus 9, and it will give us our intercepts. Alternatively, we can type 0 equals x cubed minus x squared minus x as a different example. For now, we're going to just type in intercepts y equals x squared plus 2x minus 9. So once we get in SciMath, we're going to type intercepts y equals x squared plus 2x minus 9. And we're going to enter, or we can hit the solve button. Now once it calculates, we can see that this is very similar to the graph in the same way that it calculates all sorts of different things automatically, or for example graph, asymptotes, domain, and range. We can look at how it calculates the x-intercept, which is let y equals 0 to find the x-intercepts, which is what we could have also typed, 0 equals our equation. Now it goes on how it continues to solve that. You switch the sides, you apply the quadratic formula, and you simplify the solutions. At the intercepts, x equals -1 plus the square root of 10 and -1 minus the square root of 10. It automatically calculates the y-intercept as well. It lets x equal 0 and finds the y-intercept at that point, which is -9. You can also solve equations in SciMath. Similar to how we solved for intercepts, we can solve for other equations. So to do this, you're going to type solve, you'll enter your equation, and then you'll specify for which variable. Optionally, you don't need syntax. You can type solve 3 equals 4x minus 5 for x, or you can simply type 3 equals 4x minus 5, and it knows what to do. So we're going to go over to SciMath and try that now. So we're going to type 3 equals 4x minus 5. After it solves this, it's going to walk you through how it gets to the solution. It adds 5 to both sides, it simplifies 3 plus 5 to 8, and then it divides by 4. This simplifies to x equals 2. It does this for all sorts of different algebra, and it can be very helpful if you're struggling with understanding how the algebra is working behind the scenes. SciMath also solves a system of equations. In doing this, you're going to type your first equation, then you're going to enter a semicolon, then you're going to type your second equation, enter a semicolon, and so on and so forth. As an example, you can type x plus y equals 3, semicolon, x minus y equals 1, and it will automatically know that it should solve for the system of equations. You can also type something a little more complicated, like x plus y plus z equals 4, semicolon, x minus y plus z equals 7, semicolon, and x plus y minus z equals 15. In doing this, it will solve for the system of equations automatically. We're going to go over to SciMath and do this now. So first we're going to type x plus y equals 3. We're going to hit our semicolon. Then we're going to type x minus y equals 1. I'm going to hit solve and see what our answer is. When it gets done calculating, SciMath shows you multiple ways to arrive at the solution. At this point, we're looking at the substitution method in solving for x and y. We can also look at the elimination method. And similarly, we can look at the matrix method for solving systems of equations. So there are lots of ways that you can solve these equations, and SciMath shows you multiple ways to solve the equations. Once again, it's very helpful as you're working on and learning algebra. Now we're going to go back to our slideshow and we'll move forward into derivatives. The syntax for derivatives is differentiate, you specify your equation, and you specify for which variable. Optionally, you can just type differentiate equation if you don't have multiple variables. For example, you can type differentiate x squared plus 3x minus 1 for x, or you can just type differentiate x squared plus 3x minus 1. So we're going to go over to SciMath and we're going to try this now. So back in SciMath, we're going to type differentiate x squared plus 3x minus 1. We're going to hit enter, or we can click the solve button, and it shows you how it comes to the solution. It applies the power rule, and our answer is 2x plus 3. Going back to our slideshow, we will move into second derivatives. To calculate second derivatives in SciMath, we simply use the syntax differentiate equation, and you specify for which variables to differentiate. In this case, we're going to use 4x for x, meaning we differentiate for x twice. An example of this is differentiate x cubed minus 3x squared for x for x. So we're going to go over to SciMath and we're going to plug that in right now. In SciMath, we're going to type differentiate, and then we're going to type x cubed minus 3x squared. And then we're going to specify 4x for x. And we're going to hit solve. Now you can see up at the top it did interpret our input correctly. So we are calculating x cubed minus 3x squared, and we're taking the second derivative of that. At first we apply the power rule, and then we apply the power rule again for an answer of 6x minus 6. Moving into partial derivatives, we simply type the syntax differentiate, specify our equation, and then we say for which variable we want to differentiate. As an example, we can type differentiate x times y squared for y, or we can also type differentiate x times y squared for x. We're going to go over to SciMath and we're going to try that now. So we'll type differentiate x times y squared for y. In doing this, SciMath calculates for the derivative of y in this partial derivative. So it does this while holding x constant. The solution is then 2xy. Moving into higher order partial derivatives, the syntax is simply differentiate, you specify your equation, and you specify for which variables you want to differentiate. So if you want to differentiate for x and then for y, you can do that in SciMath. As an example, you can type differentiate x squared times y squared for x and then for y. You can also type in harder equations for x, for y, so on, so forth, as many times as you want it to differentiate the equations. For now, we're just going to type in the simple one. So we're going to differentiate x squared times y squared for x and then for y. In calculating this, SciMath uses the power rule to differentiate for x, and then it uses the power rule to differentiate for y. The solution, therefore, is 4xy. Special cases do exist in SciMath. For example, natural log should be represented as ln open parentheses x closed parentheses. The base of natural log should be represented as e, just like it always is. E to the x would be the same. Similarly, pi can be written simply as pi. Other trigonometric functions are as normally used. For example, sine of x is simply sin open parentheses x closed parentheses. Other functions follow the same normal protocols. If you have any questions, comments, or suggestions, use the discussion. As always, thanks for listening.